these two systems in electrostatics. The system is system of two charges and the other one is system of dipole in electric field. Let us estimate the potential energy in this system. The system is system of two charges. It may be same charge, both having positive charge or both having negative charge, and the other possibility is one is positive charge, other is negative charge. but I am taking here both are having positive charge and Q2 is the amount of charge at this point, Q1 is the amount of charge at this point. What is meant by potential energy of the system? That system. It is the amount of work done in bringing the charges from a distance of infinity to a distance of r in between them. That is, at infinity, the charges are separated in such a way that there is no electrostatic force between them. In this state or configuration, the charges having electrostatic force, it may be of course electrostatic repulsion or it is in between them at distance. So we have to do work, that is, work is done on the system. We must do work on these charges. It is called as external work. Energy, that is, work is from the external side. To bring them closer to this, because it is electrostatic repulsion, it will not allow to come closer. So work has to be done on these charges to bring them closer to this distance. That amount of work done, it has become, the amount of work done changes what amount of work is done on these two charges will change into energy and store up as potential energy of the system. So that amount of work is called as potential energy of the system. So in accordance with the this definition, work done bringing these charges from infinity to this distance is given by this mathematical expression. So it is in a differential function, differential form, that is amount of work done is equal to same as potential energy for infinitesimal change. U stands for potential energy of the system. It is a force into displacement, usual notation. Force into displacement is infinitesimal change, differential functions. For finite changes, we take the integral function, that is integral of this, integral of this and integral of this. So we take the integration of this is W u, and integration of the function, that is force. What is the force is operating? Electrostatic force, that is given by Coulomb's law. Electrostatic force is Coulomb's constant into Q2, Q1, magnitude of the charges. This charge and this charge divided by distance of separation r square. That is the force, interaction of electrostatic force into dr. And displacement from infinity, that is initially it is the distance of separation is infinity, and final state this configuration distance of separation is r. So limit is infinity to r. So now we can go for integration of this function. This is a function of r. R is a function, therefore this stands constants. K, Q2, Q1 are constant, will be taken out of the integral sign. So integration of this function, the function of r. So we integration of 1 over r square with respect to 1 over r square with respect to dr is minus 1 by r. Integral of this 1 by r square is minus 1 by r. Then apply the limits infinity to r. So integration is over. Apply the limits for this integrated. So that this with r equals r. The first term is minus of 1 over r minus of this 1 over minus of this minus 1 over r infinity. That is 1 by infinity is 0 plus 0. Minus of minus plus it is 0. So simplify we get what is u is equal to minus k q2 q1 by r. That is the amount of work is done on the charges to bring them closer like this. That is depends on that is amount of charges deposits inversely to the distance of separation. That is the work. So minus stands for work is done on the system because you are doing work against the electric field. Minus. So minus is the one when the charges possess the same charge, either positive charge or negative charge. What about if the charges possess one is positive charge, other is negative charge? See that this is positive charge. If we take q1 is equal to minus q1, that is q1. So now it becomes what is that positive symbol. What is that sign becomes positive sign u. So magnitude remains same. What does it mean? If the charges are different, one is positive or negative charge, now work is not done on the system. Work is done by the system itself. So here work done because electrostatic force will attract themselves. So that is work is done by the system. That amount of work done will store up as kinetic energy. Amount of work done by the system itself. So it becomes what is that energy and store up as potential energy of the system. Look at this. That is potential energy is work done on the system and the potential energy work done by the system if the charges have different sign. So this is the equation we have derived. On the basis what is using this equation, we can estimate what is the amount of potential energy stored up if you have charges like this or the distance of separation between them in the system like this. This is one derivation. Let us see what is the estimation for the potential energy of the dipole in the electric field. Recall what is dipole. Dipole means this is dipole. One end is positive charge, other end is negative charge. Q both have same charges and a distance of separation of course 2L. And this stands for dipole moment. This dipole has dipole moment. This is the direction of the dipole moment. It is equal to Q into 2L, distance of separation of course. That is direction of dipole moment. This is the direction of the electric field. The dipole is in the electric field, uniform electric field. So if that is the case, what happens? So this dipole will rotate itself in the clockwise direction because of interaction. That is interaction of force between the force because of this charge and the electric field. So this charge actually is what is that pulling in this direction. This charge is pulling in this direction. As a result of this, this line dipole will rotate in the field in the clockwise direction. So it is work done by the dipole by itself. It is the one. What is potential energy of this system? The potential energy is actually work is done. What is that? If you rotate this dipole in the opposite direction, clockwise it is rotating by itself. So it is the force. What is that? This that is force becomes what is that? What is called torque force, rotational force. Torque has both vector now. This is a vector, vector direction is also vector. Vector direction is perpendicular to these two directions. So torque, what is that? Torque is a vector force. So potential energy of this dipole is actually amount of work done, that is amount of work is done on this dipole to rotate this dipole in the opposite direction like this against the electric field. So that is, if you do that work what is that change into energy and stored up in the system as potential energy of this dipole. So potential energy of this dipole is the amount of work we are doing, that is external work against the electric field to rotate this dipole in the direction opposite to what is that clockwise. Anti-clockwise means anti-clockwise, in direction anti-clockwise. That amount of work done, it is called as potential energy of the system. What is the mathematical definition for amount of work done on this fixed at this point? So amount of work done is equal to dW, or is equal to same as potential energy. It is equal to force into displacement. What is the force operating here? Here torque force, that is rotating in this anti-clockwise, and displacement. So this displacement means linear displacement with distance, but the displacement here is rotation. So we talk the displacement in terms of theta, that is d theta. So there is of course it is a differential function. Torque force into d theta becomes it is du dw, differential function. For finite values, we go for the integral functions. That is the integration of this, integration of this. The torque force, recall that what is the torque force? That is the amount of torque is P into E into sin theta. It is a cross product of these two, that is P sin theta. Recall this definition of torque force from the previous class. That is, we have done it. Theta is the angle of inclination between this plane and this plane. This plane represents dipole moment of this dipole. This plane represents electric field. Right. Angle of separation between these two fields and this field and this field. So torque force into d theta. So let us substitute for T is equal to P sin theta into d theta. Now this is a function of theta. So sin theta into d theta. Integrate, and these two becomes constant. Take it out of the constant. From theta 1 to theta. That is what amount of work you are doing from rotating this in the clockwise, anti-clockwise. From angle, that is initial angle is theta 1, initial, that is final angle is theta. From theta 1 to theta 2, what rotation? Degree is amount of rotation, magnitude of rotation. Initially it is theta 1 and theta 2. So the amount of work done depends on what is that angle of rotation, theta 1 to theta 1. Do the integration, it gives the potential energy of the system. So that is integration of sin theta with respect to theta is minus cos theta. Integration of sin theta is minus cos theta. Apply the limits, theta 1 to theta 2. And with the limits, upper limit and lower limit, minus of cos theta 2 minus of minus cos theta 1 becomes plus. Now, so first one plus is taken as plus minus of cos theta 1 minus cos theta 2. Look at this. So this is what the amount of work it is done on the electrode is that dipole moment. External work to rotate this in this direction from theta 1 to theta. Let us say some theta 1 to some theta 2 like this. Some other line. So that is the potential energy stored up in the system as potential energy of this system. So that is the potential energy expression, the mathematical equation for this potential energy is P into cos theta 1 minus cos theta 2. It depends on what is that angle of rotation. These are of course fixed for this dipole moment and the electric field. So for this system, it is depends on the angle of rotation, magnitude of rotation, the amount of work or potential energy of the system. Let us see, this is a mathematical expression, or there is a amount of potential energy of the system. This mathematical formula. Let us see what are the possibilities. Let us estimate what is the amount of that is potential energy when we have different that is angle of rotation. That is one possible. That is one case. If theta 1 is equal to theta 2 equals 0, that means direction of this and direction of this same direction. That is, this line is coinciding with this line and the direction is same. That means theta equals 0. When theta equals 0, substitute this theta 1 is same, theta 2 is same, that is 0. When this line and this line are coinciding and the directions are same direction, then what is the value, possible value of potential energy? That is cos 0 minus cos 0, 1 minus 1 equals 0. That is minimum value. What is the potential energy? When this line is coinciding with this line and the same direction, there is no potential energy. 0 is the potential energy. So it is a minimum value possible for the potential energy of the system. If the other possibility is, if this line stands perpendicular to this line, so if this line is along this line and this line is this line 90 degree, that is initially that is 0. That is 0. If you rotate this line from this, that is not 0 to this 90 degree, what is the amount of potential energy of the system? That is theta 1 is equal to 0, theta 2 is equal to 90 degree. Theta 2 equals 90 degree. They are perpendicular to each other. These two, that is vectors, are perpendicular to each other. Substitute for this. That is cos theta 1 0 is 1, cos 90 is 0. That is cos 0 is 1, cos 90 is 0. 1 minus 0 is P. So amount of potential energy is equal to dipole moment into electric field. That is the possible value of this in this system. So what is the other possible values? That is, this is one. If this line, what is that? Coinciding with line but in the opposite direction. This, when Q is here, minus Q is here. So this dipole moment is in the opposite direction of this electric field. That is theta 1 equals 0, theta 2 equals 180 degree. If you rotate this line along this line into exactly 180 degree, what would be the amount of work done? That is, what is the amount of potential energy of the system? It is theta 2 equals to 180 degree. That is, they are in the opposite direction. These are in the opposite direction. Substitute for theta 1 and theta 2. See that. So theta 1 cos 0 is equal to 1 minus of cos, that is 180 is minus 1. So minus of minus is plus. That is totally 2 into PE. So that is a possible value of potential energy. That is a maximum value when they are in opposite directions. Look at that. The potential energy of the system oscillate between 0 and 2 PE. Minimum is 0, maximum is 2 into PE. So in between, what is that? Any other values are possible. There is one value possible between when the line is here like this. So the minimum possible value of U is equal to this and maximum possible value of U is equal to this for this potential energy for this system. So that is the expression, that is the mathematical expression for the calculation or estimation of potential energy of this system. So we can determine the potential energy for any degree of rotation. By theta, what is initial value and what is theta, we can able to estimate what is the possible potential energy of that system. So it is the work done against the electric field. If you rotate this, work is done on the system. If it rotates in the clockwise, work is done by the system. So if you rotate it and hold it, the energy stored up, potential energy, release it, you rotate what is that in the clockwise direction. That's changed into work done by the system. So it's a conversion of interconversion of work and potential energy. So work is done on the system rotating in the clockwise. Work is done by the system rotating in the anti-clockwise. Work is done by the system in the clockwise system. So that is the expression for the potential energy of this system. That is dipole in the electric field. So let us wind it up.